Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to figure out how to calculate the entropy change of a chemical reaction quantitatively. In the last video, we talked about looking at a chemical reaction and determining if the entropy change is positive or negative qualitatively, but in this video, we're going to try to figure out what that is quantitatively. But just for a quick review from the last lesson, okay, you're going to say, hey, is the entropy change going up or down? Is it positive or negative for this chemical reaction? Since everything is in the same state of matter, we can't use state changes to determine if that entropy change is going to be positive or negative. But what we can use is the number of molecules. There's one nitrogen molecule and 3 hydrogen molecules on the left-hand side. So there's 4 on the left-hand side, but only 2 on the right-hand side. So that looks like this thing is becoming organized, okay? And entropy is a measure of disorder. So if it's getting organized, the disorder is going down. So I would predict that this is going to have a small negative entropy change based on, our last video and analyzing things qualitatively. But this video is about measuring things quantitatively. In order to do that, you're going to need some thermodynamic values. Now, these thermodynamic values are typically in the back of the textbook in the appendix section, okay? And I'm just going to look up the values for each of these substances in that appendix. And when I look up nitrogen, I find out that it has an entropy of 191.5, and the units on that is going to be joules per mole Kelvin. When I look up the hydrogen, it's 130.6 joules per mole Kelvin. And when I look up NH3, it's 192. Try that again. 192.5 joules per mole Kelvin. Now, just like enthalpy change, entropy change is calculated the same manner. What we're going to do in order to calculate the enthalpy change of this chemical reaction is we are going to sum up the entropy change for the products, and we're going to subtract the sum of the entropy change of the reactants. Okay, so it's the same thing as enthalpy. It's just products minus reactants. Okay, now remember, we do have to multiply this by how many moles there are. There's 1 mole of nitrogen, and that's how these moles are going to cancel out. Now we got to do 3 times the moles for hydrogen, okay, and then 2 times the moles for the NH3, okay. So when we sum up 1 times 191.5, that's just 191.5. 3 times 130.6 is 391.8. And when we sum those two things together, we get 583.3. Okay, this side is a little bit easier. We just sum up the 2 times 192.5, and that gives us 385. And then it's just products minus the reactants. So 385 minus the 583.3 is going to give us an answer of 198.3, but that's going to be a negative 198.3. I'm just going to double check my notes. It is. And remember, because the moles canceled out, okay, that unit is going to be in joules per Kelvin. So the entropy change of this chemical reaction is indeed negative, but overall it's going to be a fairly small negative change. And that's how you calculate the entropy change of a chemical reaction quantitatively. If this content was helpful, please give it a like and subscribe. And when you add that comment, it really pushes this information out to other students that might be interested in learning chemistry.